SAMA is an acronym standing for Scientific Apparatus Makers Association, referring to a unique form of diagram used primarily in the power generation industry to document control strategies. These diagrams focus on the flow of information within a control system rather than the process piping or instrument interconnections. The general flow of a SAMA diagram is top to bottom with process sensing instruments such as transmitters located at the top and the final control element located at the bottom. What are you seeing right now is an example of a SAMA diagram showing a flow transmitter sensing a process variable signal to a PID controller, which then sends a manipulated variable signal to the flow control valve. SAMA diagrams may show varying degrees of detail about the control strategies they document. For example, you may see the manual controls represented as a separate entity in a SAMA diagram. Apart from the basic PID controller function, in the example below, we see a transfer block and two manual adjustment blocks, providing a human operator the ability to separately adjust the controller set point and output manipulated variables, the transfer between automatic and manual modes. Rectangular blocks such as the P, I, and D shown in this diagram represent automatic functions. Diamond-shaped blocks such as the A and T blocks are manual functions which must be set by the human operator. Showing even more detail, the following SAMA diagram indicates the presence of a set point tracking in the controller algorithm, the feature that forces the set point value to equal the process variable value anytime the controller is in manual mode. Here we see a new type of line. Dashed line is used instead of solid. This has meaning in the world of SAMA diagrams. Solid lines represent analog signals such as process variable, set point, and manipulated variable. Dashed lines represent discrete on-off signals. In this case, auto manual state of the controller commanding the PID algorithm to get its set point from either the operator's input or the process variable input. The table on the left shows enclosure symbols that represent the various elements or functions of a control system. These enclosure symbols are tied together by the continuation symbols shown at the table on the right. And then this table shows the signal processing symbols used to describe functions within each enclosure. Some of these, especially the most commonly used, will be shown in the slideshow in the next subtopic. What you can see right now is an epic example of a SAMA diagram. Just by looking, you can say that it is a 3-element steam drum level controller. The steam flow, drum level, and feed water flow transmitters at the top, also showing several functions such as summation, function generator, multiplier, and then the PID controllers, auto manual stations, and the final control element.